Well, hi, good morning, and thanks so much for joining me in my shop here, where I'm going to go to the next step with this radio. Just thinking about what the next step might be. So, other than the possibility of some kind of weak or low performance, the radio works really quite well, but has a hum in it that can be heard if you turn the volume up high enough. Now, it's possible that hum is just nothing of any real consequence, but I'm going to continue pursuing that, I think. And in thinking about it, perhaps what might be of value to do here is one of the sections of the big filter capacitor here is busy trying to quiet the screen circuitry through the radio for the screens of the tubes that have them. I wonder if maybe that has not is not doing its job very well, and maybe just replacing that one portion of this 3-section capacitor might eliminate the buzzy hum. The buzzy hum. That's what I'm thinking. So coming out of this guy are 4 wires. One is black. It goes straight to the power. So this is the return, or the common, or the negative. These 3 are positive. Normally in these capacitors you have 2 large sections for the main filter, and then you have a smaller section in here, a lower voltage section that's meant for bypassing the output tube cathode resistor. I'm talking kind of sporadically here because while I'm talking I'm thinking about other stuff. So yeah, so here we are in the voltages here, 150, 150, and 25. So the 25 is clearly the part of this capacitor that's meant to be the bypass, and that's a 20 microfarad. And what color? How can I spot it? You gotta tell me. Here we are. Yellow. So this is the bypass. So these other 2 are working in the primary part of the filter. It would normally be a pi type filter off the green and red wire, maybe with a resistor in between, or maybe with a choke coil. I don't believe there's any choke coil in here, and I see a big resistor right here. And if we look just for a moment, we just got a little more light here for me. So this red wire attaches to a terminal that attaches to one end of this resistor. The green wire comes around to here. It does not attach to the other end of this big resistor. Oh, there's a whole pile of wires kind of piled up in here. Where's that resistor? So the resistor is tying to another terminal on this tube socket. So what I'm trying to figure out is which one of these 2 is going to be responsible. Which one is the second part of the pi filter? The second part of the pi filter will be utilized for the screen circuit. And probably an easy way. So this is the rectifier tube here. An easy way would be, well, let's see, the green comes to this tube and the yellow comes to this tube. This is the output tube. So one of these terminals is going to be the screen. There's not a spare. The tube's falling out. The tube is just falling right out. That's better. So we'll take a look at the output tube pin out. We'll find which one is the screen, and then probably this. I'm going to take a wild guess. The yellow wire will be it. No, the yellow wire can't be. It has to be the green wire by deduction. By deduction. Let's see if my deduction's right. So I think the green wire is going to the screen terminal of the output tube. The output tube is a what was it? It was a 50 something, wasn't it? A 50 something. Okay, since it's falling out, let's take it out. A 50L6. 50L6. Okay, we'll take a look in the book. Let's take a look in the book. 50L6. 50L6. The screen is attached to pin number 4. Pin number 4. So we count, we go 1, 2, 3, 4. It's the green wire. So the green wire is the screen. So my theory is the hum we hear at high volume is because the capacitance that's working on this terminal is weak. This capacitor's gotten weak. So if we augment this, then according to my theory, that hum should go away or be reduced. Another thing we could do is we could cut this green wire off and test the capacitor, and we'll get to that, I'm pretty sure. We'll augment this. Now the green wire currently has, it's 150 volt 30 on it. So I'll get a similar kind of capacitor. We can kind of just tack it in for an experiment here too. These are going to all be 50s probably. 50, 50, 50. So we're going to put a 50 in there, even though the original was a 30. A negative lead, and it needs to go to the same place as this, but this place is all over the radio here. This would be the B minus connection. There's a black wire. Darn dark in here. So I have an overhead light. It's an LED light, and unfortunately it makes a little buzzy sound when it's on, so I try not to have it on while I'm in here working on camera. Where are you going? Oh my gosh. It's going right to this terminal here. That's a tough one to solder to get to. I was hoping it'd be, well, let's see, there's a wire coming off it. I think that's just it's the same wire. So, okay, so I'm looking for a handy spot somewhere over here that I can connect the negative to. It doesn't look like there is one. So what I'll do is I'll put a little extension wire. You know, maybe I'll put the capacitor here and put the extension wire on the positive side, back out to here. And we'll leave it in parallel with this, and I'll also leave it so I can connect and disconnect, so we can hear the effect of it. That's my plan. I will implement the plan. Okay, I think I'm all set up for a little experiment here. I've got the additional capacitor installed, and the positive lead is this green wire coming to here. The wire's not soldered here. I've simply hooked it. You can kind of see it in the camera. It's hooked so I can disconnect it. I want it connected when I turn the radio on, so the radio will charge the capacitor up, rather than have the empty 50 microfarad capacitor sitting here and then with the radio fully operating, connected in. That's going to take a real, that's a bit of a shock to the radio, let's put it that way. Could cause problems in the rectifier tube, so we don't want to do that. So we'll let it charge up, then we can disconnect it and hear the effect, or hear how the radio operates with just its original capacitor, and hear the difference if there is one. And you don't even have to reconnect it after that. You can also have it connected and cut away the old one. Now that's not gonna, that shouldn't really reveal anything, I don't think, come to think of it. And I have my scope here. We can take a look at the kind of hum level that's on this terminal and on the other, the red one too, just for fun. Just for fun and edification. This is better clipped right to the negative here. Safe place to clip it. How safe is this? So I've mentioned it many times, these clip leads, they have a mind of their own. You clip them in place, and sometimes there's, you know, they're spring loaded, so what, see that? That's the kind of thing that can happen. You need to have that happen under your control. Like that. So I can get to here. That's good. That's good. Let that lay there. So what's going to happen here. We're going to turn the radio on. It's going to warm up. We're going to attempt to hear the hum. Disconnect the capacitor. Hear the change. If we can do it, reconnect it, or turn the radio off at that point. Whatever. Poke around with the scope. See what kind of hum level we get on it. That should tell the story. That's for sure. All that stuff. So currently, your radio is off. I'm going to turn it on, but not really on yet because I haven't got power to the outlet. Here we go. Since I have a capacitor connected, and although I never make a mistake ever, we're going to just keep our eye on those light bulbs there. Here we go. Oh, good. So if something bad had happened in here, this light bulb would have come on full tilt. 114 volts on the outlet. Volume up, volume up. A little bit. What do we get? Patience now, patience, Jim. Give it some time. So there's that same sound I'm interested in. I really don't think it's a power supply issue myself. I would, with the new capacitor connected, I would say no difference. But I can't be sure until I disconnect it. Okay, I'm going to disconnect it, then I'm going to have a charged capacitor up around 100 volts sitting there in this radio. The wire hanging out the end of it. So the part I didn't quite figure out. I'm going to grab that wire and pull it off. And keep control of it. And not short anything. And don't jump when the soldering iron beeps and all that kind of stuff. Plus when I pull it off, the radio may go a little crazy. I don't know. Don't jump. Be bold. Bold. Can't get a grip of it here. Okay. So it's going on and off, and no difference on any account. Okay, let me put it back. Okay, may or may not be connected now. I'm gonna hook up the scope here. Try anyway. Let's see what happens on the scope. The scope's up here. Scope is on a 1 volt per division scale. It's on AC. I guess that's okay. Boom! Right off the scale. That was quite a pop. I think I reconnected the capacitor. So looking at the scope on the 1 volt scale, you can't see anything. It's as if there's nothing there. So we'll go to the we'll go 10 times. So it's 0.1 volts. What's on there? So a little bit there now. Okay, hold that there. Slow this guy down and get a look at it. So this is the hum level on this capacitor. Now let me try and make and break the additional capacitance connection here. So the hum level down a little bit. Up, down. But I can't hear that at all in the radio. Now, this is supposed to be the high filtered side of this thing, the more filtered side. So it's kind of surprising there's anything there at all. But that's 0.1 per division. So that's about, let's say let's be generous. We'll call it 0.1. It's a lie, but we'll call it 0.1. 0.1 volts out of 100. So that's like 0.1%. But it's actually much less than that. Well, the evidence is we can't hear it out of this speaker anyway. It could be the speaker is so small we just can't hear that. Off, on, off, on. So it does make some difference. Is it enough to spend the capacitor into this radio? I don't think so. Now what about that other filter? The red wire. You know what? I'm in a position to test that too. The same way. Okay, hold on. I got too many things here in my hand all at once. And an operating radio. Okay, let go of that wire. Don't go anywhere, wire. Good. So So what I'm going to do, I think, because it's a little bit dangerous, I'm going to turn the power off. I'm not even completing the words now, am I? It's a little bit dang. Oh. Well, too bad you missed that little moment of excitement there when I discharged it here. I discharged it. Was not very exciting. Did not miss much. Now we'll bring this over and position it around the red wire. This is sort of the front part of the pi filter. I assume pi filter. And okay, so it hangs there. I can grab it with my hand and actually do this. So again, we want this to charge up on startup. So hold it like this and start the radio up. It's probably not the biggest deal anyway. Oh, I think it's in contact. Okay, let's repeat the test. Don't know for sure that that's in contact. Let's get it in contact. Quickly, man. There. Okay, we get the scope here. It's a charged wire, Jen, don't forget. And we're gonna, okay, let the wire float there in space. Get this up at the scope here so you can see it. Again, the scope is a little bit sensitive, but remember what we saw last time. Here we go. Radio, oh, wow, okay, so that was a mile high, right? This is on the 1 volt. We couldn't see it on the other lead, but here, oh, we can certainly see it. Look at that. Is that what we're hearing? That's got some pretty sharp corners in it. Sharp corners. Sharp corners means high frequency components. Okay, let's attach this, but we don't hear the hum go away at all. Boom, 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 boom. It doesn't do anything to the hum. Well, sound-wise out of the speaker. So we'll put the scope on. You see the hum? You see the hum is less. More and less. And what might be interesting is what's going on the other side of this pi filter. So we'll go to the green wire. Oh yeah, so the hum level is so low we can't see it like this. 10 times stronger, now you see it. And if we knock it out of the first leg of the pi, not much difference, a little bit. Maybe a 30% reduction in that, but I don't hear anything changing in the speaker at all. So we're really missing the boat when it comes to this kind of hum here. Another possibility for this hum, a really obvious possibility, let me just move this camera here a little bit, is this connection here to the oh, I hear my cat Peanut calling. This connection for a phono input or something like that, this may be picking up noise. It doesn't seem like it does it. So the black wire is carrying the signal and I'm trying to touch it. Look, they bent the black wire around and tried to lay it up against the chassis in here. I don't know if you can't quite see that. There it is. Sort of, back there. Okay, decision time. I'm not going to waste my capacitor in this radio. I'm going to take it out. The hum level here is not enough to worry about. The hum coming from the power supply. No, let's not do that. Let's do that. So let me pull the capacitor right off here. Fooling around with the power plug. What happened to Peanut? Did he give up on me? That little hiss you just heard now is interference from my soldering iron, loud enough to trigger the squelch on the CB radio behind me. Lots of funny CB stuff last night. And I've noticed, oh man, I haven't been very vigilant, but I see the 31 meter band is hopping all day long here at my house. So if you're a short wave guy, you would probably know that, but assuming it's the same where you are. There we go. There we go. Okay, temporary capacitor out. We need a new theory now. Peanut has a new theory. Hello. That's him saying hello. My cat speaks English. Peanut. Once again, it's getting to be a bit of a routine here, isn't it? Who's at the door? It's you. I'm so surprised. What are you doing? Come on in. Peanut. Come on in. When I was a kid, I used to watch a children's TV show called Captain Kangaroo. And stuff like this happened on the Captain Kangaroo show. You know, waking up grandfather clock and all that stuff. Oh my god, I'm turning into Captain Kangaroo here. So next stage here, I think I'm going to continue to pursue this hum thing a little bit. Why don't we try silencing the audio input to the audio amplifier. We'll just silence it. Easy. I think I've got a shorting plug I could plug right in here. I would probably shorter. I can just short it with clip leads. There's a million ways to do it. Now I gotta think about this. Where would I short this? Would I short this to the chassis? If you wanted to short the, it's kind of like the output of the volume control here. So I would want to short to ground. Let's take a look at the schematic here. Okay. So what we're interested in is the silencing the input to the triode in this tube, which is coming right here. So we stuck a ground right here to the chassis or to the negative wire, which is over here. If I go to the chassis, this guy's kind of a part of the picture. I replaced this. Why don't we just try grounding this out to the chassis and see what happens? I think what I'm really doing then is I'm amplifying any noise in the chassis through the audio amplifier. I don't think that's a good idea. I think back to the negative wire is really the way to go, and probably put a nice sized capacitor over to the negative, and we'll just end the signal that's here. I mean, another way is to disconnect this, but I don't like that way. Well, then let's try that. We'll short from here to the B minus. The radio is turned off. Short from, yeah, it looked easy on the schematic. Where's that spot in here? So here's the capacitor carrying the audio from the volume control. This is the connection to the tube here. This is the part I want to put a short on. My finger won't be sufficient, so I'll use a clip lead. And the idea is we're just clip. No, B minus, Jim. Come on, keep your head about you. So B minus would be just follow would be right here. I can do it fairly safely, on and off. Clip it on. Kind of weird, I'm clipping right to one of the wires that goes to a prong that's plugged into the power outlet. That's a bit of an uncomfortable feeling. There we go. You know, there is another capacitor I was going to go after. That's the one that's right across the power line. Maybe we'll go after that guy after this. So I believe what I've done is I've silenced the grid on the triode preamp for the output tube. That's what I think I did. Okay, let's see what dim light says. Dim light says, wait a minute, 1 second. Too many things to do. Switch is on, volume is down, with the short in place. Nothing funny on the light bulb. Lots of time to warm up. Pretty darn quiet. It's got to be warmed up. Volume down. Clip lead off. Ooh, cheapers. Clip lead off. Hum is back. So I knocked the hum out by grounding the grid. So that means the hum is on the grid. Why would the hum be on the grid? It sounds to me like the impedance has just gone way too high. So I believe there's a grid ground, there's some kind of resistor on there. Let's how sensitive that is, eh? So let's take a look at that resistor. Right from the grid connection in there. Well, it's just a schmozzle for you to look at. I know that, but this, I better do something with this because this could hurt you. There. Now again, my radio is not plugged into a regular outlet. It's in an isolation transformer. So in fact, theoretically, I could take that wire that's connected to either one of these incoming power lines and ground it. Nothing bad would happen. That's an experiment I will not be performing. So now, having distracted myself, we're looking at the schematic. That's right, schematic. So I've applied the ground here and the hum completely disappeared. We have this very large resistor here, 4.7 megohms. You know, this is so high. Really, this whole thing could become an antenna here. The 0.003, I've changed that. Whoops. So I think the name of the game, we'll measure this. See if it is what it says it is. We can measure it in circuit, no problem. And then consider what we might do about this. Why is it so large? It's so large because you want the grid to be high impedance. And what's on the other side of this? B minus. Okay, let's check this resistor here. The power is on. The power is off. There we go. After complaining about my overhead light, I do have it on now so I can see. That little resistor goes between this terminal and this terminal. Come on, stay on there. Looks like it's going to settle in at about 5.5, settling in right there, 5.7. Instead of 4.7, can that be a significant change? How can that? If 5.7 makes that hum, 4.7 would too, wouldn't it? I'd have to put like a 10 megohm resistor across it to drop it down to the range it's supposed to be in, or replace it. There's a hum deal here I'm trying to sort out. There's a capacitor that comes off the other side. Yeah, what's going on in this other terminal? Is this just a spare terminal? what's going on here? 1, 2, 3. It's terminal 3 on that tube. What tube is that? Terminal 3 on the 12 SQ7. Thank you, whoever wrote that there. Terminal 3 on a 12 SQ7. SQ7. Terminal number 3 is the cathode. Wait a minute now. Terminal number 3, cathode. There's another wire I missed. Yeah, there is. There's a wire. Yeah, a wire coming around here. It's a red wire. Cathode. Okay. So let's look at what this capacitor is about. What I'm trying to figure out is this cathode tied direct back to the negative bus? I can't remember. No, it went through this capacitor, didn't it? And it goes on to this terminal. Not grounded terminal. Capacitor off of the next pin over. Doggone it. 12 SQ7. Next pin over would be pin 4. Pin 4. Well, it's just the other plate. No, not the other plate. It's one of the two plates. Pin 4 and pin 5 probably tied together. Yes, they are. Pin 4 and pin 5. And then the output, the input from here is tied right to that connection. Right to one of the diodes here, and the signal just finds its way out from there. I would have thought it'd be connected somewhere else, but that's okay. Right to there. Little capacitor. Let's look again. So 12 SQ7, a little capacitor off the cathode. Here it is. Oh, could even be this one. And they're the same size. So what's he doing here? This guy's draining out RF. As the RF path is this way. I think that's what that guy's doing. And this guy's between the plate and the cathode is probably some kind of compensatory capacitor for something. This is the one that's silencing, helping to silence. This is the one we were fooling with this morning. First thing, a big capacitor. Okay. Well, I don't know. I think really 5.7 instead of 4.7 is going to make that much difference. Maybe there's some ratio thing going on here that something I don't know. Let's change it. Do I even have a 4.7 megohm resistor? I better start right there. Do I even have one of those? 4.7 megohms. 4.7. I don't think I have resistors going that high. Yikes. 1 megohm. That's as high as I think these go. These ones. 1 megohm. Not going to make it here. Okay. Most of my parts are down here in these parts drawers. So to find a 4.7 megohm resistor. This is my 47 tray. see it says 47. Wow, if I'm going to find one in here, I'm not even going to trust it, I don't think. So that would be 47, and then the last color would have to be 47. You know what? 47. How come there's a green in that? So there's a 5. Just look for any resistor with a green third band. Should be what I'm after. Yeah, I put a 47, 4.7 in there. What if I choose to put a much lower one in there on purpose? I don't even want to go in there and change that. Here's what we'll do. We're going to leave it as is. We'll leave it as is. I'm aware of it now. I know that there's a chance that that resistor is the cause of a little extra hum. But the fact is, the volume has to be quite high to hear the hum. So perhaps I just continue on with other issues with the radio, and perhaps I lost my train of thought there. And perhaps at the end of the whole deal, if the hum is still there and the hum is a problem, then I'll continue on from this resistor, investigating it there. I think that's how I'll approach that. Now, what about the rest of all these wax capacitors? So there's probably some grid blockers in here that we should take a look at, and we can check in a couple of ways, and it might be good to start with the output tube grid blocking capacitor, and I'll bet you it's this one right here. But let's find out. So that would be pin 3 on the 50L6. Pin 3 on a 50L6. 50L6 pin number 3 is the plate. Okay, we didn't get it right there. The grid on the output tube is pin number 5. Pin number 5. Pin number 5 is 1, 2, 3. 1, 2, 3, 4, 5. This is it. So this is the grid blocker, this guy, way up here. Mr. Grid Blocker is a .02. I'm just going to glance at the schematic here to dump just for double checking .02 is correct or matches the schematic. So this is the guy. Now his job is to block the B plus from getting onto the grid here. And this little resistor's job is to bleed off any charge that does show up on the grid. There's a couple of ways the grid can pick up charge, kind of unintentionally. And if you didn't have this bleeder resistor here, or leak resistor here, then this thing would slowly build charge, probably. What we can do, we can read the voltage on this and see if it isn't the appropriate voltage. Now, this guy gets his bias from a cathode resistor. Why don't we sort that out too? Let's sort that out. The cathode resistor would be, guess what? Connected to the cathode. Again, 50L6. Cathode is pin number 8, all by itself. Pin number 8. Pin number 8 is this one. Pin number 8 has that resistor hooked up to it. And that looks like a something green something. Could be a brown, green, brown. That would be 1, 5, that'd be 150. I'm just going to glance again at the schematic here, and there's a 150 ohm resistor right there, so that's definitely it. Let's see if he's 150 ohms. These resistors, cathode resistors, often work fairly hard, get a little hot. Often they're larger wattage resistors, and anything that gets hot wears out. So 185. Just measure it in both directions here. Yeah, 185 instead of 150. So that's going to make the tube run with a little extra bias, a little less current through it, a little less quiescent current. It'll put the operating point not in the center of the range where they're targeting, but it'll put it somewhere off center. And what that means is when you turn the signal up, it's going to hit the limit earlier than if it was in the center, where you'd have all this range. So I'm going to reduce the output range of the radio. The output range of the radio will be reduced because this distortion-free output range of the radio. 150, 180, and this thing heats up. It could do something funny too. It could go further. Let's change that. We'll change that one. Okay, I'm going to put in a 150. Oh, I know. There was that capacitor across the power line I really wanted to go after. I should really do that too. And that might, maybe that's related to that, huh? I don't think so. 150 in there. Okay, I'll get that installed. Okay, resistors in. Now there's going to be a recommended bias for this tube in my manual here. 50 L6, or they're going to recommend the size of the cathode resistor. Probably what they're going to do is recommend the cathode resistor size. Oh my gosh, 50 L6. Okay, here we are. 50 L6. Looking down all the stuff here. Typical operation, plate supply 110, that's what's going on in this radio. Grid number 1, voltage minus 7.5. So we're hoping to see minus 7.5. The cathode recommended cathode bias, this is at 200 plate volts, is 180. That's kind of where we were, and I just knocked it back to 150. That's okay because we're closer to 110. Doesn't give the cathode bias resistor for 110. Oh, the fixed bias, cathode bias. Okay, never mind that. So probably we're aiming for around minus 7.5 volts. That's what we're looking for. We're going to look for minus 7.5 volts relative to the cathode. That being the case, I think I'm going to use my this meter here to look for it, because there's no grounds involved. Okay, and what am I going to do? I'm going to do this. Practice session. I'm going to put the negative on the negative, like so. You know what I'm going to do? I'm going to clip it on there, so I don't have to handle two things at once. Yeah, I can't handle two things at once. I tell my wife that all the time. Okay, so that takes care of the negative lead on the voltmeter, sort of. There we go. So I'm taking this and just touching the grid, like so. I'm hoping for a negative, I don't know, 5 volts or something of that sort. I think we're ready. Power on. Try to say that as loud as I can. Power on, so you won't hear the explosion. It might occur at the same time. Okay, let's take a look. Oh, yeah, mine's 20. Good. again. Hey, let's plug the radio in. Let's plug the radio in. Okay, so there we go. Try it again. One more try. I may have not done this right. I haven't done this right. This is wrong what I'm doing here. I should be reading the cathode. Ooh. 0. Give it some time. Wait a minute, this isn't the cathode. This is an open terminal. Think, man, think. Where was the cathode? There's just too many tubes in this world. 50L6 cathode is 8. 8, yes, 8. 8. I could have remembered that. 8, 8. 8 is the one I'm testing up here. This is cathode. There, now we're getting some voltage. Plus. Think hard now. This is the cathode relative to the chassis, relative to the negative bus. It's running 5 volts positive. That means the grid is 5 volts negative to the cathode. 5 volts is in range. It probably was 7 before I changed that resistor. So it doesn't look like this. Oh yeah. Oh, isn't that interesting? Here's that hum. Okay, so I've totally bamboozled myself here completely. Didn't I say this was the grid feeding capacitor? And what am I doing over here? This is the cathode bypass. Right, that's the cathode bypass. Right. So, grid. So if I read the grid to the cathode voltage, cathode is here. Grid is here. So it's such a high impedance here that my meter is just sucking the life out of that. Oh, I'll take that back. It's almost the same voltage, -5. That's interesting. Turn it up high. Get it up high enough you can hear that. Not touching. A lot more sensitivity was over here. This is where the signal's on its way to the triode. This is the really sensitive area. This is where this noise is being picked up for sure. But this is the problem. When we come across that resistor that's 5 megs instead of 4. So I'm going to try to parallel this across the leak resistor on the grid here. This is probably going to be a disaster. It'll drop the resistance of the grid leak. It's in place. It got noisier because it's just more metal, more antenna. We need less antenna. The antenna is this capacitor, I'm sure. So most of my capacitors now, I have done a little test and determined which is the outside foil, which is the inside foil. So you can see this capacitor has a black dot on it showing the outside foil. This one I did not do. perhaps I put it in with the outside foil connected to the grid. You know, there's another thing happening here. I think. As we change this volume control setting, change the impedance that's presented to the grid of this tube. Maybe as we turn up the volume, we're turning up the impedance of this circuit at the same time. And it's just becoming more and more of an antenna, but at the same time, program materials coming through, making this impossible to hear. Maybe that's part of the picture. Yeah, I have the volume up quite a ways now to get that to come out. I think I'm just chasing ghosts here. It is fun though. But what about the supply lead to the resistor, to the volume control? I think that's this one. So it's sensitive too. Often these are shielded wires, by the way. They use shielded stuff in here. So I'm not touching any metal here. You would know it if I did. So what other crazy thing could I do there? Well, I could flip that capacitor around. Flip this one around on the basis that I've got it in a sensitive way. Let's try that. I just keep pursuing this problem, which really may not be a problem in fact. There's a fair bit of lead on that capacitor. I think I just nip it and flip it. Okay. So I've reversed this. Does the radio still hum? That is the question. Volume is down. Plug stayed in this time. Put the power on. I think this will be my last thing for today. I mean, it could very well get noisier if this outside foil thing is an issue and I had it the right way to begin with. You know, I had the capacitor. I should have checked it. A little hard to say, isn't it? That's louder now. I think it's louder now. Yeah. Son of a gun, what a dummy. Certainly didn't go away. Okay, hear that? I'm going to stop the video. I'm going to flip that capacitor back again, and we're going to play the radio just like this. And on video, you're going to hear it go from this sound to the new sound. Okay, that's it. Capacitor back in the other way. So while I had it out, I was smart enough to check it with my oscilloscope. You can see it going up there, and all I did was just clip the capacitor. Okay, let's see if this really works. Into the scope. Okay, the scope's pretty sensitive. Wow, did you see it jump off the screen? There's a DC voltage inside this capacitor. Not a remaining charge. It's a battery effect. Okay, so now we're looking to see if we can see the hum in there. Okay, I really, there's nothing. I don't see anything in there. We'll flip it around. Not a thing. Oh my god, I got this set this way. Let's try this again. I had the scope lead set low. Okay, so now we can see that's like half a division. Now we see that's more than half a division. So I would say this is the outside foil, and if you look on the capacitor, it's marked outside foil. The difference is notable here. With this yellow capacitor, I could not tell. When I had it out, I did this exact test. I could not tell which was which. And what that maybe says to me is that it really doesn't matter. And maybe that's why the manufacturers don't market it anymore. For some reason it doesn't matter. I don't know why it wouldn't, but maybe for some reason it doesn't. So now I can't actually, like you just heard the test on video. I haven't. I can't right now at the moment. But just from listening to it, I don't think it made any difference which way I put that capacitor in there. So we discovered that really, you know, this guy is not screaming out, my capacitors are killing me. He's not at all screaming that. So I should leave everything as it is at this point. And oh no, I did want to find that the one across the the last one I should do is the one across the power line. Where is that? The hum gets quieter. The hum gets quieter on this capacitor. Outside foil, incidentally, is connected to the grid here. That's kind of backwards, isn't it? This is the grid. Don't you want the outside foil on the low impedance side? Wouldn't it be on the other side? The plate side. Is this really the grid? Did I boob up here? Or I boobed up. Yeah, no, that is the grid. I'm pretty sure of it. Which generally means I better check. Pretty sure. 50L6 and the grid is on 5. 5 is 1, 2, 3, 4. That's the grid. That's kind of interesting too. I can put my finger on the lead wire insulation here. Get on the capacitor and it has an effect. Oh, jeez. Well, I don't know. Let's change this guy. Let's do that. 0.02. It's an easy job. Carry on after the hum. Let's change that one. Okay, new guy's in. Let's test the old guy. Over here. Come on over here. Okay, 50 volts. What's the I do? Looks good. 150. So probably at 250 it won't. It's still open. So this is not the worst. This is better than most of the capacitors. Not really that bad at all. Like if we try reading the capacitance on it. Let's see how that goes. 0.02. 0.02. Oh, right there. So the eye is not really opening properly. It's just barely opening. And that's, to me, that's indicative of a leaky capacitor. The reading is 0.02 plus a little bit. It's almost 0.03 on here, in fact. And that's another indication that the capacitor is leaky. You can't test the capacitance of leaky capacitors on here. That's the bottom line. So not terrible, but it's in a very sensitive circuit. So let's see what happened now with the radio. What happened to the radio? Okay, we're all set to power up. Let me just get this out of here. Dangerous solder. Power up. Volume down. I'm going to put on, give it full juice, which is hardly any different than the restricted voltage. Volume up. I'd say it's about the same. So a piece of black wire. Don't touch that, that'll be noisy. Somewhere I have some phono shorting plugs. Let me see if I can find one of those. Well, I can't find my shorting plug, and I'd say this thing is louder than ever now, but I'm going to try to short it here. Ground first. Oh man, okay, so seems to me doing that removes one hum, reveals another. Maybe we'll leave it at that. I mean, there is a little more humming going on in here than I realized. So, okay, that's enough for today. That's enough. I gotta go play in the snow. So thanks a lot for watching, and tomorrow we'll just carry on with this radio. That'll be it. See ya.